All right, good afternoon, everybody. Thank you very much for coming out this afternoon. We have a very special broadcast for you today. It is South Carolina Hurricane Preparedness Week, and we are going to answer some of your questions. All of our social media accounts asked for what kind of questions you had for us, and we did have a great response. We got a lot of questions to go through, so we'll jump right into it. And so I did want to briefly introduce our panelists. They'll each get a chance to introduce themselves. My name is Steve LaVoie. I'm a meteorologist here at the National Weather Service office in Columbia, South Carolina. And my office is responsible for the county shown in pink, and that is typically called the Midlands region of South Carolina. My office also does have some Georgia counties as well. That would be what we call the Central Savannah River Area, or CSRA. We have from the Greenville-Spartanburg office, we have Clay Cheney. In Wilmington, North Carolina, we have Ian Boatman. Robert Bright is down at the National Weather Service office in Charleston. And also on the line with us is a representative from the South Carolina Emergency Management Division, Mr. Derek Becker. And starting off with me, again, you can see our entire CWA is in green here. This is the Columbia CWA. We are located actually in West Columbia, South Carolina. And I have been with the Weather Service since May 2021, so it's been about a year. I earned my degree in geography with a concentration in atmospheric science from Ball State University in Indiana. And I have my bachelor's degree in meteorology from Lyndon State College. And again, I work down here at NWS Columbia, serving the Midlands, which is about 18 counties of the Palmetto State, and the Central Savannah River Area, or 5 counties of Georgia, over here on the state line. And so those are the counties that we represent. So if you're coming from us from any of those locations, I would be one of your many forecasters. Next, I'll take it over to Clay.
Thanks, Steve. And like Steve said, my name is Clay Cheney, meteorologist here at the National Weather Service office in Greenville-Spartanburg, South Carolina. I've been here since March 2020. Basically, the day I started was March 16th. The next day, the entire country shut down due to COVID. So I'll always have an interesting tale to the beginning portion of my NWS career. We serve counties, 46 counties. So we have 12 counties in South Carolina, 28 in North Carolina, 6 in Georgia. That also includes, the Southern Appalachian chain, the Blue Ridge, and then you work your way into the foothills in Piedmont, North Carolina. You have the Upstate, South Carolina, which is what we're responsible for. And then you have the Upper Savannah region with the Northeast Georgia counties that we're also responsible for. So that's my tale.
Okay, we got Robert next.
All right, thanks, Steve. Yeah, I'm Bob Wright. I'm a meteorologist down here at the Charleston Forecast Office. I've been here since 2003, so it's been a while. I've seen a lot of tropical storms and hurricanes. We serve essentially the 8 counties in southeastern portion of the state, essentially the low country, and then we also cover portions of southeast Georgia. Our office is located at the airport down here in North Charleston, and yeah, so happy to be here. Thanks for setting this up.
All right, then we got Ian.
All right, cheers everyone. My name is Ian Boatman, meteorologist at the National Weather Service in Wilmington, North Carolina. Little ironic, we're located in North Carolina, but we actually cover more counties in South Carolina. We cover a total of 14 counties, 8 of them in Northeast South Carolina and 6 of them in Southeast North Carolina. The South Carolina, the counties, the bigger parts of them include the cities of Myrtle Beach and Florence. I was born and raised in Augusta, Georgia, part of the CSRA. I am very intimately familiar with the CSRA and the Midlands and on the way up to Northeast Georgia. Went to the University of Georgia. How about them dogs, defending national champions for the first time in my life. That's what I do around here. I've been here since December 2019, so about 2.5 years at this point. Love my time here and love to be part of this webinar to teach you all a thing or two about hurricanes and how South Carolina is affected by them. Cheers, everyone.
All right, and last but not least, representing SCEMD, we've got Derek Becker on the line.
Hey everyone, well, like I said, my name is Derek Becker. I'm the Chief of Public Information here at the South Carolina Emergency Management Division. And if you're not familiar with EMD or what we do, we're the primary coordinating agency for any major disaster that occurs in South Carolina, whether it be hurricanes like Hurricane Prep Week, earthquakes like we've seen all too common in the past few months, but anything that could potentially put people in harm's way, we coordinate that response here. I'm coming to you from the State Emergency Operations Center in West Columbia, which is just outside of the capital in Columbia, but we have our regional folks throughout every region. We have 6 regions in South Carolina, and we have folks stationed to support all of our 46 county emergency managers. And it is Hurricane Prep Week, so our theme this year is Know Your Zone, Prep Your Home, and Remember Your Route. And I hope we can get into that a little bit later. So back to you.
All right, thanks for that, Derek. All right, so I thought we'd start out with a look at the official NOAA 2022 Atlantic Hurricane Season Outlook. And unfortunately, we are calling for another above normal season with 14 to 21 named storms, 6 to 10 hurricanes, and 3 to 6 major hurricanes. A major hurricane is defined with winds sustained at 111 miles per hour or higher. That's also a Category 3, 4, or 5 on the Saffir-Simpson hurricane wind scale. And just to take a look here, these are the numbers from 2021 season. And so in 2021, we had 21 named storms. We actually used the entire predetermined list. We had 7 hurricanes and 4 major class hurricanes. The list that we have shown is originally used in the year 1980. This was the same list that was available in 2016 with 2 new names, and those are going to be Martin and Owen. Those replace Matthew, which of course was a very serious hurricane in the southeastern US, and also Otto, which was a late season hurricane that struck Central America. So those are 2 new names, along with 3 names that have never been used before, but are on the list again. Those would be Tobias, Virginie, and Walter. Okay, and I thought we'd open this up with a little bit of an icebreaker. So we'll do a little roundtable discussion, and actually our last question will also be in roundtable format. And so the question is, why did you choose your career in meteorology or emergency management? And I will go first. I was born and raised in New England, northwest of Boston. And my first love, I was always in love with meteorology, but my first love was definitely hurricanes. And it was this hurricane shown on the left in particular that set me on the path that I was destined for. This is Hurricane Bob from 1991. So I'm showing my age a little bit there. I had just started first grade I was just about to start first grade when Bob impacted New England. And Bob is actually the last hurricane to strike New England. So it's been quite a while for that part of the world. And with that, I'll turn it over to Clay. Oop. Clay, are you there?
Whoops, sorry, forgot to unmute myself. But as I was saying, basically I got into weather at a very young age. Really, I was like 2 or 3 years old. I used to live with my grandparents for about the first 7 years of my life. And of course, you know, older folks tend to watch the news more. And so I think I got pretty intrigued with the weather segments when the news did come on. And then I found the Weather Channel, and that kind of just took things off from there. And I guess a big one for me, kind of like you, hurricanes was what I first got into. Mine is actually Katrina. I was in I was either in second or third grade when Katrina happened. So that's kind of what really sparked my interest. And like I said, I kind of just took off with it after finding the Weather Channel as well. So.
All right. And how about you, Ian?
Yeah, Weather Channel was definitely what did me in. I was the ripe old age of 6 years old when I had it figured out. I remember getting ready to go to school in the mornings, and the Weather Channel's morning show at that time, they had Marshall Seas and Heather Tesh every morning during the weekdays. I remember their names. I remember watching them in the morning. And of course, Jim Cantori, some people call him the Can Man. Everybody's kind of inspired by that. I remember, listening to his voice on Storm Stories and listening to the smooth jazz music on Local on the 8s and stuff like that. And when I was 6 years old, I'm like, boom, yeah, I'm gonna do that. So originally broadcast was my first love. And when I went to UGA, my first 2.5 years were in the broadcast sector and basically saw more cons than pros, at least for me, and decided to go in a different direction. And the National Weather Service was one of those things that I kind of kept in my back pocket. It wasn't the only thing, but it was certainly one of the things that stuck out. So the Weather Channel had a lot to do with it, and just having a local attention to weather in the area. It always seemed like when I grew up that Allendale and Screven and Aiken County would get warnings put on them all the time, and Burke County in Georgia. So I would always be conscious of severe thunderstorm warning, tornado warning here and there, and watching other storms pop around me. So that's what got me hooked, and here I am to this day.
Awesome. All right, our last meteorologist, Robert.
Yeah, well, like you guys, a big weather event kind of got me intrigued. I'm originally from Philadelphia, pretty much grew up in New Jersey. And of course I remember Hurricane Bob, but Hurricane Gloria was actually the storm that got me really interested. And I was probably in 5th grade or so, and I know we had off from school that day. Super exciting, went outside, to play in it, and we actually just got brushed, so we didn't get hit too bad where I was, but that kind of intrigued me and kind of started the path. And then I actually had a 6th grade science teacher who loved the weather herself, and then she actually made us watch the Weather Channel for a project. So that really was great for me. That really got me piqued my interest there even more. And then then from there I pretty much went to I was a little scared about all the math and the science I had to take in school, but I was lucky enough to get in and get my degree at Rutgers University for a bachelor's, and then I went to NC State for my master's, and been here ever since. So certainly not a bad place to start my career, and we'll see if I end it here, but yeah, just glad to be here. And actually, I have a real strong interest as well in helping people. So, it's more than just the science, the physical science of it all. So it's that social science aspect and actually helping people prepare and be ready. So.
Awesome. All right, and our last panelist here, we're gonna go to Derek. What got you into emergency management?
I've been here so long, I don't remember ever, doing something else before. I'm just kidding. So prior to coming to EMD here in 2008, I was a reporter and anchor for a couple of TV stations here in the Columbia market. But my first job in broadcasting was actually when I was 16. That was Channel 7, WSPA in the Upstate, just a little next generation report for Friday Night Football or whatever. But when I was working for ABC, we had done a lot of work with the Emergency Management Division in 2004, that hurricane season with Charlie, Francis, Gaston, Ivan, and Jean. And I think Francis was the one that just tore into Shaw Air Force Base. And we went in and did a few stories in there. And then, of course, the next year in September with Hurricane Katrina, all of the evacuees that we brought from New Orleans to the Columbia area, and working at the time as a reporter, working with my predecessors here at the Emergency Management Division, who I worked with for a number of years after that. And just remember being very fascinated in the planning aspect of it, what goes into managing the emergencies, police, fire, EMS, you kind of know what they do just by their very nature. But emergency management is that branch of public safety that brings everybody together, from the weather service forecasters to the local first responders to the federal partners to the National Guard and everybody, and gets everybody on the same page. We're kind of like the party planners of emergencies or hurricanes, if you will. And that's the fascination. 14 years later, many hurricanes, a couple of floods, a few ice storms, and we're still going strong. And this agency really is one of the best in the country in terms of state emergency management agencies. And I don't think I would want to work anywhere else.
Wow, that's great. Well, thank you everyone for sharing. Now we'll get to the Q&A portion. Our first question comes from Twitter user Zarita Floridian, who asked NWS Columbia, I moved from Florida and have been through several bad hurricanes there. After hurricane barbecue parties are real because everyone has to use what's in the freezer and fridge when you lose electricity. Once 3 to 4 weeks, another week, another 3 days. So her question is, what kind of historic events and damage has occurred in this state? And what kind of short or long-term disruptions have occurred? Well, as you can see on screen, I selected the 4 most notable hurricane landfalls since HURDAT, the hurricane database, started in 1851. The one that almost everyone here in the Palmetto State will know about is Hugo, a Category 4 hurricane that came ashore in September of 1989. It made landfall near Charleston with winds of nearly 140 miles per hour. Hurricane force gusts they stretched well inland, much further inland than a typical hurricane would bring. For example, Fort Sumter had a gust of 109 miles per hour as the eye passed just to the south of them. So that's something we'll talk about actually in another question about the impacts up in the upstate. On the coast, obviously, there was massive damage. The small fishing town shown here of McClellanville was hit particularly hard by Hugo. And there was quite a bit of a gap in major hurricane activity, but in the 1950s, if you're native to South Carolina, maybe your parents or grandparents remember Gracie or Hazel. Gracie was also a Category 4, made landfall with winds of about 130 miles per hour, and landfall was done just west of Edisto Island. It produced an 8.14 foot surge in Charleston Harbor, and that was during low tide. And so sometimes we see that the storm surge is higher when we have higher astronomical tides. So it's very fortunate that it was only 8 feet, not much higher. This is considered the worst storm in the history of Beaufort, South Carolina, as that was people who were interviewed after Gracie would say. So it's the strongest storm they can remember in recent memory. And of course, that would probably go for other communities such as Paris Island, shown here as well. We do know that from Gracie, electric and water was unavailable for weeks, particularly in Beaufort County. And then just 5 years prior to that was Hurricane Hazel, a late season hurricane. It made landfall near North Myrtle Beach, South Carolina, with winds about 130 miles per hour. So very similar to Gracie. This hurricane made landfall very close to the North Carolina-South Carolina border, officially right around North Myrtle Beach. This storm was it tracked generally to the east of South Carolina. So South Carolina, the majority of the state was on the weaker side of Hazel. So that's why many would remember Gracie over Hazel of the two. However, Myrtle Beach did see a gust of 106 miles per hour during Hazel and the high lunar tide. So this one hit at high tide and it nearly wiped out Garden City, South Carolina. What Hazel is probably better known for are its impacts to the state of North Carolina, and then as a post-tropical cyclone, when it moved into the Northeast and especially up in Canada, it caused devastating flooding and high winds in that location. And finally, the 4th hurricane we're going to talk about happened so long ago, it was before meteorologists even named them. And when a hurricane was particularly impactful, they would give it an unofficial name. And this hurricane in the lower right corner, it was called the Great Charleston Hurricane. And it was a Category 3 that made landfall in South Carolina in 1893 as a Category 3 hurricane with winds of about 120 miles per hour. Now, from my research, it looks like there was a very similar hurricane of strength that actually struck Georgia about a month prior. It was known as the Sea Islands Hurricane and killed about 1,000 to 2,000 people, primarily on the coast of Georgia. So that hurricane didn't make direct landfall in South Carolina, but still caused massive devastation in the state. And the main thing we know about the Great Charleston hurricane is that aid from the Red Cross and other organizations was delayed even further when this second hurricane moved through. All right, take it, I'll pass it over to Clay now.
All right, so the question that I get to receive, what was the highest known wind speed from Hugo in upstate South Carolina? So I did my research. There wasn't a lot of available observation sites then, especially as many as we have now. The main ASOS or observation site that we had then was here in Greenville-Spartanburg. The highest observed gust was 45 miles per hour. Likely higher the farther east in the upstate you go, like out towards Chester and York counties. That's where the eye of Hugo actually crossed into the eastern parts of our county warning area. And basically it lifted, kind of just west of Charlotte and then through the mountains and foothills of North Carolina as a tropical storm. I'm pretty sure it was still considered a Category 1 hurricane even when it entered Chester and York County. And then pretty much once it crossed the state line is when it got downgraded to like a tropical storm and then eventually the remnants. So the highest recorded gust at GSP was 45 miles per hour. There actually was an 87 mile per hour gust in Charlotte. I know that's not in the upstate, but it's pretty close to the state line. So that can probably give you an indication of what kind of gusts they were seeing out in York and Chester County, maybe even out towards like Cherokee or Union. So it was definitely the most impactful tropical cyclone for the upstate of South Carolina. I tried to look back and I even got in contact with somebody from the climate office to try and find more data to see if we could actually see what the highest recorded wind gust from a tropical system was in the upstate. The next highest was actually Gracie from 1959, the one you were referring to, Steve. And I think Greenville-Spartanburg got up to only a gust of 29 miles per hour. So to answer the last question, Hugo was also the highest recorded wind gust from a tropical system in the upstate of South Carolina. So fingers crossed for no more Hugos.
All right. Another question from GSP.
Is this still me or is this?
Nope.
Oh, okay.
No, I believe this is Ian's question.
Oh, excuse me. You know what? That's right. Sorry about that. Yeah, so we are the ones that actually click the button to issue your tropical storm watches, warnings, hurricane watches, warnings, etc. That all comes from your local weather service office. So if Horry County, Myrtle Beach folks, when they get a hurricane warning, we are the ones that issue that. That comes from this office here, and we're the ones that do that. However, that comes with very, very, very close coordination. We don't do anything really until we coordinate with all of our friends around us. That includes Columbia, that includes Charleston, that includes to our east, it would be Morehead City, North Carolina. All of your neighboring offices have to be on the same page because as you imagine, it is a big moment of communication. Everybody's got to be right on the same page from top to bottom among all the weather service folks, among all the meteorologists in general, because you're coordinating with others in different facets. The broadcasters, for example, you want to make sure you're on page with your emergency managers at the city level, county level, state level, federal level, even if you have a really, really big event. And of course, the National Hurricane Center itself. We are in constant communication, perhaps with them more than anybody else, with the folks down in Miami. We'll have coordination calls beforehand when we have a next big update. Say, okay, you know, Horry County, they're not in a warning right now, but in the next update, it's going to come out in the next 2 hours, 3 hours, what have you. You know what, we're going to put those folks in a warning because now it's starting to be crunch time. So all of that is decided kind of in-house, and that is close coordination with everybody. So even though we're the ones that click the button at the end of the day, that's not necessarily an independent decision that we come up with. That is a very intimate decision that is made among a lot of different folks at once. So it's just one person that clicks the button, but you have a bunch of other people behind you that are all supporting the same idea. So that's the logic behind the watches and the warnings and who issues them and how all of that works.
Awesome. Well, thank you for that, Ian. Our next question comes from Facebook, and Robert has our answer.
Hopefully. So the question was, how does dust from the Sahara suppress tropical activity? And, you know, I think the science is still evolving a little bit on this, but the general thought is that you can think of that dusty area as just a big, dry air mass. And, you know, when you talk about tropical cyclones, you obviously don't like dry air. So essentially what that dry air does is it just limits the thunderstorm activity. And so if the thunderstorms can't get growing, they can't get organized, they can't strengthen, and they, you know, you can't really get your tropical cyclone to develop. Also in that layer, you typically have some stronger winds, and that creates wind shear in the atmosphere. So you got winds at different levels going in different directions or different speeds, and that can disrupt the thunderstorm activity. So that is obviously not good, not conducive for thunderstorms to develop and tropical cyclones to develop. And one other point is that the dust can block the sunlight from reaching the ocean and can also prevent it from warming up. And tropical cyclones like warm water. So you keep the oceans a little bit cooler, that's a little bit less energy for the tropical cyclones.
Cool. Thank you for that, Robert. And next up here is another Facebook question. Comes from Kim Osteen, who asked, do all areas in South Carolina have hurricane zones or just at the coast? And so what I have displayed here are the current South Carolina hurricane evacuation zones. In the state, we actually divide this between a northern hurricane region, central, and southern. And so I tried to demarcate the boundaries between each zone here. And you can see that we have a zone A and a zone B in each one. So this is very critical first to know exactly where you are or where your property, friends, and family are, and which zone specifically you're in. So if a hurricane strikes, you'll need to know where it is. And you can see that they're not exclusively just at the coast. In fact, this zone H goes almost all the way to Clarendon County in my county warning area. So this is not just, again, exclusively within a few miles of the coast. If a hurricane is bad enough, the research has been done on which areas are most likely to flood. And so you need to know, for example, if you're in zone H, because that one in particular, like I said, goes far out. Zone G is another one that you can see goes well into Berkeley County as well. So certainly it's a little bit further away from the coast that we need to worry about. And you can see it all depends. For example, way up here in the Myrtle Beach area, it is more exclusively to the coast, but then it does stretch further out. If you're in, or if you think you're in an evacuation zone, the best way to find out is to go to this map at the web address shown below. That's from the SCEMD themselves. And they have a map where you can zoom in.
No, let me chime in here. New resource.
Oh.
We launched it last year, a brand new resource. It's an online interactive hurricane guide because the emergency management division and our county emergency managers coordinated the zones. You go to hurricane.sc, and it takes you through all of the steps from prepping your home to knowing your zone. You can also download the SC Emergency Manager mobile app, and there's a map tool in there. And you just say, share my location, and it instantly tells you what hurricane evacuation zone you're in. So just wanted to chime in there and tell you those two resources. Now, yes, you can download the maps on those websites on our main website, but we have a much cooler, a much more interactive version at hurricane.sc and in the South Carolina Emergency Manager mobile app, and that's in the Apple App Store and on Google Play.
Awesome. Well, thank you for chiming in there, Derek. Heard it from the research themselves, so that's definitely the place to go and get the most up-to-date information. Another question here. This came from Drayton Gilliard, and he asked, what does tropical versus non-tropical system mean? And so we have tropical cyclones and then non-tropical cyclones, which we often call mid-latitude cyclones. And there are many differences between the two. Some of the biggest differences are tropical cyclones are what we call a warm core system. That means that the interior of a tropical cyclone is typically warmer. That environment is warmer than the surrounding area. Whereas mid-latitude cyclones are cold core. So typically the center of a mid-latitude cyclone will be colder than the surrounding area. Another really big differentiation between the two, a system would not be classified as a tropical cyclone if it had any frontal boundaries. Mid-latitude cyclones will get their energy from the collision of two air masses. And so the interaction with air masses and fronts and temperature and moisture differences will be what drives a mid-latitude cyclone. And of course, when two air masses come together, that's where we'll have our frontal boundaries. A tropical cyclone, as I mentioned, would not have any fronts at all. They will derive their heat actually from warm ocean waters, as Robert pointed out earlier. And so we get energy for hurricanes from warm ocean water, and it's a process called latent heat, and it releases energy and gives it to the tropical cyclone. Tropical cyclones will form exclusively over the waters of the tropical and subtropical oceans of the world, whereas a mid-latitude cyclone can form over land or water. And the strongest winds with a tropical cyclone, they're typically very symmetrical in their wind field, and they're typically very near the center. Now, of course, with a hurricane, the direct center is going to have very light winds, but the most intense winds with a hurricane are going to be right around it in what we call the eye wall. In a mid-latitude cyclone, oftentimes the strongest winds are going to be far removed from the center itself. And so we'll see some situations as we'll get to where they're far removed from the center, such as in a lot of subtropical cyclones have that. And also, again, most tropical cyclones, especially hurricanes, when they're fully mature, will have a very symmetrical shape, and a mid-latitude cyclone will not oftentimes. So the fronts will give it an asymmetric look and other features. Now, I did want to touch on the kind of Venn diagram I made here in the middle. Subtropical cyclones, they are warm core, non-frontal systems often. And the biggest difference here is that they share traits with both tropical and non-tropical cyclones. So for example, a subtropical storm will have its warm core, but maybe the strongest winds are far removed from the center. So we need to see a little bit more organization. We need to see better development, thunderstorms wrapping around the center before a subtropical cyclone would be considered fully tropical. And we have had cases, many cases, where tropical cyclones have, started subtropical and then eventually made it right back to non-tropical. And there are rare occasions when a non-tropical cyclone will actually go in the reverse order and acquire tropical characteristics. So there's a lot of overlap between the two, but eventually, like I said, there's a big difference here between a hurricane, which is fully tropical, and then your normal mid-latitude cyclone. All right, and back to Clay with another Twitter question.
All right, so with my question, it says, can you explain the upper level anticyclone feature atop a tropical cyclone? So typically, whenever you get an upper level anticyclone develops over top of a tropical cyclone, basically that comes within, as Steve was referring to, with it being a warm core low. So such as that, you could either get large scale sinking from, you know, a subtropical ridge. And so with that, you tend to actually weaken any sort of tropical cyclone genesis, just because it suppresses any kind of convection that you have, and it typically has, you know, some kind of temperature inversion, so it'll cap any sort of deep convection that comes along with it. You can also get a subtropical ridge. With these subtropical ridge, especially around the peripheral of them, that can actually dictate the direction that the storm's going to move. So that's one way that it actually plays a role into it. Let's see, what's the other one? Anticyclone plus low pressure seem to contradict. So to kind of just continue on that basis, the evolution, of course, of an anticyclone depends, of course, on the size and intensity of the lower level cyclonic circulation that goes within that, you know, tropical cyclone. Basically, for strong, I'm trying to think, sorry, I've had a long day, but for strong tropical cyclones, you can actually, an anticyclone can actually enhance the convection that goes along with that, just because you have, you know, large heat fluxes and vorticity, basically due more so just because of the position of the, you know, the larger lower scale cyclonic circulation that you have. So this is actually could produce pretty rapid tropical cyclone genesis. And so with that, it more or less just depends on the size of the actual hurricane, and that'll be more dependent on whether or not you get rapid intensification, or with a weak tropical cyclone, you tend to get more horizontal, like stronger horizontal wind shear. So that can also just kind of derail any kind of rapid intensification that comes with the tropical cyclone. So that's kind of the backstory of that and the role that it plays. It just kind of varies depending on, like I said, the size of the tropical cyclone and how rapidly is it intensifying, or if it's just kind of stagnant, and you know, this, you know, anticyclone up above it can derail it in that way. So it just has a lot of variables that come with it. You can also kind of look back on, like, you know, how much moist convection do you have. You can even throw in the Coriolis force if you want to. So there's a lot of variables that go into that with anticyclones aloft, but that's kind of the role that it tends to play. And I'm pretty sure there's more research that could be done to, you know, figure out the correlation between the two. But as of right now, that's pretty much what we know.
Awesome. Thanks a lot, Clay. And then we've got a question here for Ian to go over.
Yeah, what types of flooding can hurricane bring? We'll focus on the coast first, and then we'll move inland. So there's two different kinds of flooding that's associated with a hurricane. You have your storm surge flooding, and then you have just what is called inland flooding. If you actually live in a coastal region, then you potentially could deal with a double whammy effect, if you will, because you could actually have two of these things occurring in a similar kind of area. I know parts of the Wilmington area and some of the beach towns can have both storm surge flooding and inland flooding. Your storm surge flooding, just think of that basically as coastal flooding on steroids. You're having these massive, think about how powerful a hurricane is and compare that to you throwing a rock in a pond, right? The bigger rocks you throw in that pond, the bigger waves that you're causing. Well, imagine you throw a hurricane in there, you're really shaking things up, right? And that's why you see all these big waves that come in, high surf that comes into the area. So all those waves crash upon shore, and they're going to go way more inland than they usually do. And that's the storm surge flooding. And you can look up in certain areas and towns the amount of inundation, the amount of feet above ground level that will happen with a certain kind of storm that will bring in 2 feet of storm surge, 6 feet, 8 feet, 12 feet, on and on it goes. One thing that sticks out in my mind, in Wrightsville Beach, North Carolina, to talk about our neighboring state for just a second. Wrightsville Beach, North Carolina, it's the closest beach town to Wilmington. You go along one of the main streets that's right before you hit the beach. They actually have this pole that shows you the inundation that they've seen in the past. And that's where the storm surge is. And if you stand next to that pole and kind of look around you at the buildings, you know, you have this restaurant there, that shop there, and you're like, whoa, all of this stuff is completely underwater from this storm and that storm, and on it goes. Locally around these parts, folks might think about Hurricane Florence in 2018. And that kind of leads me into the next point. Hurricane Florence in 2018, for those that may not remember, was supposed to be a Category 4 hurricane when it made landfall. And thankfully, it weakened significantly. By the time it made landfall, it was a 1. But we do have a little bit of a flaw with the hurricane scale that we use, which, by the way, is called the Saffir-Simpson scale. Operates from Category 1 to 5. 1 is the weakest and 5 is the strongest. But the problem with the scale is that it only talks about wind speed. And that makes that scale pretty one-dimensional. Because wind speed, though it is a problem, and it needs to be talked about, rightfully so, you have other factors of a hurricane to worry about. And in fact, flooding might actually be the worst one because it's known to be the deadliest. And this is where you have a lot of inland flooding that takes place, which is just when you have a ton of rain fall on a particular area. Hurricane Florence made landfall as just a Category 1, no big deal, right? That was the problem. It was a slow-moving storm and dumped a ton of rain upon this area. That's where your inland flooding comes in, right? So parts of inland South Carolina, like in Florence, they saw a lot of flooding. And you got to think about, you know, if you live near a river or stream, right? South Carolina folks, hey, do you live near Lake Moultrie? How about Stevens Creek? How about the Santee River? Places like that. Over the Georgia border, Rays Creek, where I played around as a kid and got near some famous bridge one day somewhere. But, you know, that is the problem with inland flooding. And those are the two differences between them. And that's the kind of multi-faceted damages that hurricanes can bring along. So while wind speed is important to pay attention to, flooding is actually the deadliest. And that's what we've seen over decades of data, going back over a lot of storms. So those are the types of flooding to be aware of between storm surge and inland flooding.
Awesome. Thank you so much for that, Ian. Another question coming up. And this one will be for Robert.
Yep, so the question is, do hurricanes typically have stronger winds than tornadoes? And, oh, there you go. And as you can see, the different scales on the left, we have that Saffir-Simpson scale for hurricanes, Category 1 to 5. And you can see the highest wind speed, 157 miles an hour or greater. But if you look on the right at the EF or Enhanced Fujita scale for tornadoes, you can see the highest is over 200 miles an hour. So from my research, I found that, you know, we've measured some winds, I think over 300 miles an hour from a tornado. Now, granted, it's very difficult to take these measurements, but, you know, you certainly can have winds a lot stronger in a tornado. Now, compared to a hurricane obviously lasts a lot longer, it's a lot bigger. So the impacts can be much different and much worse in a hurricane, just because it's going to cover a larger area and it's going to last a lot longer. So it's something that we really need to keep, you know, pay attention to. And, you know, hurricanes can produce tornadoes as well. So within the larger swath, hurricane wind swath, you can have these embedded tornadoes, which really do, you know, extra damage and, you know, make things a lot worse in local areas. So.
Awesome. All right. So thank you for that. Next question, we'll go back to Ian.
It's a great one here. What items should be included in my disaster supply kit? How many days of food and water should I have on hand? I'll actually expand upon this a little bit. I'll answer those 2 questions. I'm going to take this a little bit further because this just leads into disaster prep in general. And with the first day of hurricane season being tomorrow on June 1st, there's some really good things to cover here that expands upon what we have listed here. As it pertains to food and water, really good things here to remember. Get yourself non-perishable foods, canned food, non-perishable stuff, granola bars, what have you, right? Pick up a big box of granola bars, take that with you. Canned food, stuff that's not going to expire immediately, right? Pick up a can of something that expires in 2026, then you're good. Make sure you have water with you. 1 gallon of water per person per day, okay? And that is for up to 3 to 7 days, okay? So if you got yourself a family of 3 for 3 days, let's do the math on that for a second. 1 gallon per person per day, so that's 3 gallons every day for a mom and a dad and a kid, if you will, for 3 days. So 3, 6, 9 gallons of water for that time period. Food, get yourself a non-electric can opener. That's kind of the stuff that people don't necessarily think about. That's why we want to kind of fill in some of the gaps here. A lot of people have electric can openers, which is great, but ooh, power's out. That doesn't help you. Get yourself one of those old twist-off can openers. I have one at my place. Paper plates, plastic utensils, stuff like that. Medicines, both the over-the-counter stuff and whatever prescriptions you have. Make sure you have a supply of that can go out up to 30 days, right? Because even though maybe you get power back within a week, you still have other supply chain stuff to worry about. Maybe the pharmacy in town that you typically go to is not restocked on ibuprofen or any of the other prescription meds that you may have to think about for yourself. Make sure you have other stuff around you. A battery powered radio, okay? Tune in to local radio stations, get some good info around town. Hello, NOAA weather radio, folks. Go to your local grocery store, get yourself a good NOAA weather radio. Okay, they're very, very good. We put out the alerts on it. You'll be kept up to date with that. Flashlights and lanterns. I have a personal anecdote with this. The first tropical system that I covered with this office was Hurricane Isaias in early August of 2020. I worked 2 overtime shifts in association with that event. Both of them were night shifts. Worked one of the night shifts, came back, power was out at my apartment, no surprise, I knew that was gonna happen. I got ready for the next shift and I was gonna take a shower, and then I had my flashlight and I'm like, oh, I have to awkwardly point my flashlight towards the shower to make sure, you know, I'm not naked in the dark with water on my head. TMI, if you will, but hey, who cares? And then that made me think, you know, if I had a lantern, I could just kind of set that sucker, you know, on my bathroom countertop and then I'm good. Instead of having to worry about pointing that flashlight and maybe rolls off the counter or whatever, don't worry about that. So that's why you get both flashlights and lanterns. If you're able to get solar powered anything, flashlights, lanterns, what have you, that's great. If you stick to the battery powered stuff, make sure you get your batteries, right? Your AA's, your AAA's, the D's, the C batteries, whatever you need to get. Cash, make sure you have some cash on you. ATMs will be out for an extended period of time, as will the banks. You don't know when that stuff is going to come back exactly. You want to have liquidated cash to take care of you and your family immediately. So take out cash ahead of time. Stock that in a drawer somewhere, put it in a safe. Put other stuff in your safe that you might need. Bank account information, social security info, what have you. Really good things to remember. Fill up your car in advance. And if you're able to, go get a little mini grill or griddle, so that way you can do a little cooking there. Buy the little teeny tiny camping size propane tanks to go with that stuff. Get a cooler, not only fill it with ice, but hey, if you're able to get some dry ice, okay, last you a little bit longer than traditional frozen water ice would. Fill up your bathtub beforehand, so you have another extra supply of clean water at your disposal. The gallon water jugs, you can buy the big water dispensers, you know, the office water dispensers, if you will, with the big 5-gallon jugs. As it pertains to clothing, make sure you have good rain gear on you. Your place might get flooded a little bit. Maybe your basement ends up getting flooded. Well, you'll have to deal with that at a later day. But if you have a rain jacket or rain boots or stuff like that, that helps keep you dry. Make sure you have that stuff you can easily grab it at any time. Secure the loose items. You got patio furniture outside, bring that stuff in. You got towels hanging up out there because you were at the pool the other day, bring it in. Not only are you protecting yourself and your property, but you don't want that patio umbrella to blow off and hit your neighbor's window. Speaking of windows, let's board up those windows. Other little things to think about ahead of time. Take a look at insurance policies. And in fact, that might be one of the first things you should do, because getting flood insurance may involve a 30-day waiting period. And you can't really wait that amount of time if there's a hurricane immediately in the forecast. Do this now. Actually was looking at my insurance the other day, kind of thinking about this kind of thing and what I need to do to prepare for this upcoming season. Look up your address. Where do you live? Is that in a floodplain? And think about what you need to do if that ends up being the case. There's another thing that I just saw a year ago. If you need to evacuate and kind of hide some of your stuff or take care of some of your stuff, say you have some really valuable picture frames or your diploma hanging on your wall. Take it off the wall, put it in the racks of your dishwasher. Brilliant. I never thought of that. And I saw that on the Weather Channel, I think like a year ago or so. And I'm like, oh, that's smart. That would make a lot of sense to me. Oh, but I see somebody, Derek is shaking his head there. He might have something to say. What you got, Derek?
No, absolutely not. You got to remember, dishwashers, washing machines, they have outputs, and during floods, they can turn into inputs. And so if you put items in your dishwasher in a flood, especially a hurricane with storm surge, you've just ruined all your precious valuables. The best advice we can give you for making sure your important documents and things like that, put them in a Ziploc bag and carry them with you, or put them in another watertight container in your attic if you are in a low-lying area or somewhere like that and you can't take them with you. Another option, I know we like hanging on to the paper copies of things, but digitally scan them and save them in your cloud.
Excellent. Yes, thank you so much for that. It's something I didn't think about. So scratch the dishwasher idea completely. Derek, thank you for bringing that up. That is an excellent point. That's all I have for this question. I want to make sure I kind of covered a lot of bases here because it just goes beyond the simple food and water question. So I hope that brought in a lot of answers to the table.
Great. All right. Thank you, Derek and Ian. And our final question, which we'll go back to that roundtable style we opened with, came from John W. Rankin, John CU71, Twitter user. If you had a blank check to improve forecasting abilities for hurricanes, what's the first thing you'd spend money on? And so I'll start us off. I personally am in favor of having as much data getting ingested as possible. So in a perfect world, I would have ideally remote and deployable surface observation, little weather stations like this, just more compact. Not only right along the coast, this is something that we are working on. So little installable stations, but also something that they tried out last hurricane season would be to have something over the water as well. There aren't a lot of observation stations, maybe ships, buoys, but definitely anything that we can get to improve what is going on right now on the, on the ground and in the adjacent ocean. Sometimes we have situations where hurricanes rapidly intensify before landfall. And so if we had that information, some distant ocean sensors, we could know what's going on a little bit faster. And then that data, of course, would go into our computer models and help improve the accuracy of our forecast. So that is what I would spend things on first. I'll open it up to the other panelists now.
Yeah, so for me, I'm kind of in line with what Steve was saying, just having more data to kind of roam through and look at as the storm is either, coming off the African coast and churning through, the Eastern Atlantic and making its way towards, the Caribbean and out toward the mainland. And even when it's close by, even if it's formed by a local wave, and that sort of thing. But I also wouldn't mind going off the spectrum a little bit. And I thought about this, what if there was a way we could either have some kind of like multitude of like drones, since drones are used a lot for like tornadoes now. What if we were able to, you know, fly them out towards a hurricane and then have like continuous data kind of scanning through these hurricanes that could pick up what it's doing, like, you know, minute observations, 5-minute observations, hourly observations, that sort of thing. I know that's kind of off the spectrum a little bit, but I just, you know, whenever my mind gets a little creative, I tend to think about those kind of things. So I just thought that idea would be pretty cool if we could actually do it.
Cool. Anybody else?
Yeah, I read a scientific article the other day. It was published about a year ago, maybe 2 years ago. Somebody out in California did some research with intensity forecasts with hurricanes. Kind of the whole thing around here is your hurricane track forecasts are usually pretty doggone good. The intensity ones, although they've gotten a lot better and they still are good, they're just not as good as we can do with track. So a lot of talk is kind of focused on hurricane intensities with that forecasting and how can we get better at that. Embrace the future, embrace technology. This one paper used AI as a capability, artificial intelligence, to be able to better forecast hurricane intensities. And they kind of separated a couple of hurricane seasons out and developed an AI model and said, okay, you know, how good is this AI model able to do against the seasons that we asked it to forecast? And it seemed to do pretty doggone good. So hey, AI, you know, a lot of other technologies going in that direction anyway. So if we can sign that blank check and throw a bunch of money at that to see how that could better our intensity forecast, hey, let's jump in. I'm all for it. So I'd like to see some AI in there. That'd be fun.
Cool. Robert or Derek, anything else?
Nope.
Well, I guess when it comes to the forecasting abilities, you know, when the launch of the GOES satellite, for us as emergency managers, being able to work with Columbia and Charleston and Wilmington, and GSP, in addition to the National Hurricane Center, I'd improve maybe the connectivity between all the offices to make sure that everyone is on a consistent set of messaging. You know, we do that to some extent during a disaster, but there's always ways to do that better. There's always new people coming in or new technology that needs to be updated. But really looking at the ways that you know, National Weather Service can be further integrated with emergency management or public safety in general, maybe in co-sharing space or something like that. But that's really what I would like to see, and really, you know, bring the team closer together.
Cool. And Robert, did you want to add anything?
No, I'm good. You guys did a good job covering it. So
Awesome. Well, with that in mind, that was our final question. So I did want to thank everyone in the audience for sticking with us here. And thank you for those who submitted questions on our social media accounts. This is the fourth Q&A I've hosted, and the first one that we've brought other participants in. So an extra special thanks to Clay, Ian, Robert, and Derek for their participation today. And again, thank you everyone for attending, and remember to always be weather aware.